Hey, hello, welcome to the show. It's me, JP, and it's time for JP's product pick of the week, and I've got a good one for you. So I am so glad that you could join me and we could provide you with an opportunity to check out this super cool product and get a ginormous discount on it today. So before I go any further, I will tell you where you can check it out if you want to jump over to the product page. That right there is the URL. Head over there, or darn it, to that QR code in the corner. I have a mirrored view of myself, so I'm often pointing the wrong direction. That's my excuse at least. But if you head there to that QR code or this URL, you can check out this week's product pick, and it is 50% off. All you have to do is throw it in your cart and you'll get it for that price. There's no coupon code needed. You can get up to 10 of them. But what even is this thing? Well, before I tell you, I'm going to have Lady Ada jump back just a little bit in time. It's a pretty new product, and tell you all about it herself. So take it away, Lady Ada.
Okay, next up, we've got a PAM8302 breakout. We've had a breakout board version of this, like breadboard friendly version, for a long time, but I wanted one that's plug and play, that is pre-soldered, ready to go. You don't have to do any soldering to get it working. You have terminal block on one end for the speaker. You have the JST for audio input on the other. And it's just a kind of nice, 3-watt Class D amp, low cost, simple. By default, it gives you about 14 dB of gain, but into a 4 ohm or 8 ohm load. But if you look at the next photo, there is a little volume control knob. It's a potentiometer that you can twist to reduce the input from, it can be up to 3 volts peak to peak input. You can reduce it down to reduce the gain so you don't blow out your setup. So I have a little demo.
We have a demo.
I have a demo showing the kind of configuration, because there's, we have a lot of amplifiers, and I'll explain why you'd want one or the other.
Fun.
So what's nice here is that, again, it's solder free. This is a prototype. It's green. The final version is blue or black. But green, I don't know. Sometimes I'm feeling green. Inside there's a JST 2mm PH input and you can use, we have cables that are like $1 a piece. Black is ground, red is power, 3 or 5 volts will work, and then white is signal in. And the signal is capacitively coupled here, so it can be DC reference. It doesn't matter. We'll AC couple it on the input. And then the potentiometer is the gain. And then there's the amplifier. There's a couple capacitors, and then output you can is a bridge tied load to, in this case, it's a 4 ohm speaker, and up to 3 watts. So it's fairly loud, and I don't want to get us into YouTube trouble, so I'm just going to quickly turn it up.
Stop it.
Okay.
Wait.
Great.
YouTube police.
YouTube police.
Everyone's a cop now too. Everyone's just.
It's
like
it's cop city.
They're just like, I'm gonna turn you in because you're doing something.
Yeah, I know. But this is great. Like, for example, this is Circuit Python, and it has 3 volt peak to peak output. But I also tried this with line level output from my computer, and it works great. Because you have enough gain. And then you can use use any flathead screwdriver to adjust the gain, and don't play copyright music ever. Works with pretty much anything. It's just straight analog audio in to Class D amplifier out. Very simple, but really great when you just have microcontroller audio, PWM or pure DAC output, and you want to amplify to a speaker.
Yes, that's it indeed. Let me give you a little preview of it right there. That is my product pick of the week this week. It is the PAM8302 STEMMA audio amplifier. It's a mono 2.5 watt amplifier, and it is pretty plug and play. You can see here I've got a little speaker here, not a set, just a single speaker here plugged into the screw terminal for the speaker output, and then we have a little STEMMA 3-pin plug that you can plug into your project and get the audio power and ground reference over to the board. So let me plug this one in and give you a little demo of it. I'm gonna adjust some cameras here first, and let's Let's do a little bump up of exposure there, and I'll fix that focus. There we are. Okay, so you can see what I have right now are a QT Py with the output that I need to do PWM audio over one pin. I'm choosing the MOSI pin, and then power and ground. I'm just going to plug those right into the little PAM8302 audio amplifier. I've got a little potentiometer on there that I can use to adjust the gain, and then this is running out to the speaker. So I'm just going to power this up over USB. Let's see, I can adjust the volume down and up.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
And that's just going to loop. This is wave files that I'm playing using CircuitPython, and I'll show you in a second what that code looks like. But this is really nice and easy to use. You can see here you've got a lot of options for how to plug that in. You can use screw terminal shields, and you can use any header pins that you might have on a board, or something like a feather doubler if you want to plug in some cables of this type. We have both male and female versions of these little 3-pin JST connectors. In this case, I just soldered directly to the board, and you can make a nice little neat package of that. It's even got some mounting holes on there. Got your speaker, maybe mount some stuff up like that. So this is really good for your wireless, or rather your wearable projects. This is a really good one for battery operated portable projects. I'll give you a little look at the board right there. You can see we have, it's a fixed gain. So this, I think this says max 14 dB 5X, and then you can adjust the gain by about 24 dB using your potentiometer, but the actual wiring of it is a fixed gain. It will do up to 2.5 watts on the 4 ohm speakers, and then that'll vary. It'll get cut in half if you go up to an 8 ohm speaker, so depending on the resistance there, or the impedance. You've got the ability to drive your speakers directly, so you don't need to go through some intermediary object. You just plug directly into there. In fact, it's the only way to do this. You don't want to plug this out to another amplifier. What else? It's it's Class D mono, so you're not going to get stereo out of this, but it works really well over things like a PWM pin, which is what I'm using in this case, or you can do a analog out pin. So let me show you another example here. I'm going to set this off to the side, and I will show you this example here. I'm going to move some camera just a little further out even. I'll get some stuff off the screen there. Let's move my camera off to the side a little bit. I'll focus this. So here you can see I built a little project into a box here. I've got a Grand Central, which has a analog DAC output I can use, so my audio is coming out analog rather than the PWM pin in the other project. So I have analog coming out over A0 into my little STEMMA amplifier there, and then out to this nice big juicy speaker. And then I'm driving SynthIO stuff on there. So that last project was playing wave files. This one's using SynthIO and CircuitPython. And then I'm sequencing SynthIO with this Norns Shield XL from our good friend of Adafruit, Steve Denki Otto Noreko. So this, when I start this, is going to be just sending MIDI notes over USB to the Grand Central, which is then going to use SynthIO to play those, and you're going to hear all that nice sound coming over the large speaker there through the amplifier. So let me hit play on this. And again, I can adjust volume on the amp itself. So that's at full volume, which is also, of course, tempered by code, what I'm telling the maximum volume to be in code. And I'm also getting some nice resonance from this wooden box that I've screwed the speaker into to act as a soundboard. And that's a little picture of the sequencer there that's running this. Go back and stop that. So really nice, handy for this type of a small project. Maybe this is going to be a battery-operated project, or maybe you're just trying to get things neat and small and tucked away. This is a really nice option for doing a single speaker, decent sound, but a nice small portable type of project with the amp there. So if you want to take a look at, this is, let me turn off this second mic here. Yeah, and Todd made a point over in our Discord. This is the Discord happening over here. Yeah, normally you would adjust the gain one time with your screwdriver. So get it to the spot where it's loud but not overdriving your speaker, and then you can do adjustments in software. You wouldn't really expect to go in there with a screwdriver a whole bunch to adjust that tiny little trim pot. Good point. So if you take a look here, this is the page here. This is product 5647, and you can get it for $2.48 today. You can get up to 10 of them per customer. And if you take a look here in the links below, there's a Learn Guide that we can check out by Kattni, and this gives you an overview of the amp, tells you some of the specifications, things like you can run this from anywhere 2 to 5.5 volts DC to power it. It is a very efficient amp, talks about efficiency and the types of speakers that you can run on it. And then we have an example of the pinout here, as well as some example code that you can use in both CircuitPython to play some tones and some wave files, and from your Arduino as well. And those examples work well with both PWM outputs and analog outputs if you have a board that has a true analog output. If you take a look in our downloads section of the Learn Guide, you can get more info about the chip itself. This is the PAM8302. Talks about specs on the chip, as well as typical applications. They suggest, I always like seeing these, what they thought they were putting it out in the market for: GPS, portable speakers, walkie-talkies, hands-free phone, speakerphone, cellular phones. So those are just some of the uses that you can come up with for this, but it's inexpensive, easy to use, pretty much solder-free once you have a wiring solution on one end for this JST connector. And by the way, if you take a look in our main page here for the product, you will see, if you're not aware of this, when you go to add something to the cart, you can also say, oh, you know what, let me include some of the cables that goes with it, or sometimes there's other products that go with it. But here you could say, yeah, I want a JST PH 2mm 3-pin to male header cable, and that'll allow you to plug into something like the board that I have here, my Grand Central, which has these female header pins already plugged into it. So those just plug right in and you're good to go. Let's see, what else? Am I missing anything? Let me know if you have any questions over in the chats. Thanks for stopping by over in our YouTube chat as well. The Quinman16 in YouTube says they need to make the volume controller over I2C. Yeah, you could certainly do that if you use something like one of our breakout STEMMA QT encoder boards. You could have your code looking at that to adjust the volume. And speaking of code, I said I would show you what some of this code looks like. So this is from my wave player example here. I'll turn this back on for a second. You'll hear it. Playing some music there with this little ported speaker. So I'll turn that back off. That code is that the one right here? Yeah, so you can see somewhat typical stuff for bringing in audio files, wave files, and playing them. I'm looking through a couple of directories and playing whatever I find in there that ends with wave. The key thing here is this one is importing audio IO PWM IO as the audio out, and I'm choosing the, in this case, the MOSI pin, and that was just because it was convenient on the Cutie Pie there to put all those in a row there. I could do the MOSI pin for PWM audio out and then ground and power, or power and ground next to those. If you look at my other example code, this was the SynthIO code based on one of Toddbot's excellent synthesizers, SynthIO MIDI synth. And I just made some adjustments to it. The key thing being I'm using audio I/O with the DAC, so my audio code right here is audio equals audio I/O dot audio out, and then I'm picking one of my analog output pins. So that uses the DAC rather than the PWM. Arguably, you'll get better sound from that, depending on your speaker size, the type of sound you're putting out over it, the type of effect you're going for. You can also make the PWM output filter through an RC filter if you want, depending on your needs. But I didn't in the case of this Cutie Pie. I just wired it directly to the amp, and it works pretty well. Let's see. I think that's going to do it. So thanks, everyone, for stopping by. That's it right there. And that, let me go ahead and unplug this and sign us out. So I can unplug that from the Cutie Pie. It's just screw terminals to plug that into your speaker leads. So I can take a tiny little screwdriver there. It's a little flathead. I think Lamore secretly favors tiny flathead screws over Phillips. So that right there is my product pick of the week this week. It is the Max 8302 STEMMA Audio Amp, Class D Mono 2.5 watt amplifier. Thanks everyone for coming by. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week. Don't forget, you can head on over here until the end of the show. Throw these in your cart. You will get them at half off today, 50% off for the audio amp. Thanks everyone. For Adafruit Industries, I'm John Park. I will see you next time. Bye-bye.